Precision medicine in treatment of colorectal cancer means we have to separate the notion of colon cancer as one entity into many entities, into many colon cancers by distinct molecular nature of the tumors. And about 15% of colorectal cancer tumors have a specific genetic change called microsatellite instability. And microsatellite instability in colon cancer tumor is very important for treatment selection and also for prognostic purposes. What is microsatellite instability in colon cancer, and what is the role of microsatellite instability for personalizing the treatment and for prognosis in colorectal cancer?
Okay, excellent question. Let's go back and get a little historical perspective for about 10 seconds. In the old days, I mean, anytime before the mid-1990s, the only characteristics that we could use to distinguish one colon cancer from another was it well differentiated, was it poorly differentiated to make a lot of mucin. None of those things were terribly helpful, and we didn't use them at all for any therapeutic decisions. But then, when microsatellite instability was discovered, and microsatellite instability is this genetic signature in which microsatellite sequences, which are short, repetitive sequences like a whole series of adenines in a row or a whole series of CAs in a row, just repeated over and over. They're all throughout our genome. They tend to be replicated exactly from parent cell to daughter cell, but they require the DNA mismatch repair system for that to happen properly. So in cancers with defective DNA mismatch repair activity, they can't replicate those sequences well. And the tumor gets hundreds of thousands of mutations of these sequences. So we've selected ones that are very sensitive, selected microsatellite sequences that are very sensitive to the loss of DNA mismatch repair activity. And you can do a simple test. And if there are more than 2 out of 5, if there are 2 or more microsatellite sequences that are mutated, that's microsatellite instability. So the first thing we found was that led us to virtually all of the Lynch syndrome cases and this other 12% that had methylation-related silencing of the MLH1 gene. And so that told us about familiality, but it also, in a short period of time, we realized that those tumors with microsatellite instability did not respond in the same way to chemotherapy. They didn't get any additional benefit. In fact, there was some degree of additional harm that was added by using them. But also, the tumors that had microsatellite instability had a